Day 38, Honors Physics, Statics, problem number 15. This one's going to be involved. So I have my initial step, once again the red diagram, the three forces that are concurrent on that point of intersection. We know we have 10-pound force straight down. I'm leaving off the units for now. The answers will have pounds in them, so just to keep it simpler, we'll put that back in at the end. I have one rope, T sub 1, pulling up at 60 degrees with respect to the ceiling, and the other rope pulling slightly down and to the left at the 75-degree angle. Now this is what's a little bit complicated is that rope T sub 2 is pulling down and to the left. So T sub 2y, if you look at my blue diagram, is down. It's helping out with the 10. In other words, T sub 1y is going to be a little tighter, or it's going to be the sum of T sub 2y plus 10, because we have to have equilibrium in that blue diagram. So here's how the algebra starts to fall out here. Let me write this down. I have to have, for equilibrium, I need T sub 2x equal to T sub 1x. And I need to have T sub 1y equal to the sum of T sub 2y plus 10. So there's going to be a lot going on here we have to keep track of. So what I'm going to do now is I'm going to find the components, expressions for the components of T sub 1 and T sub 2. Once again, it's a standard procedure in these statics problems is drawing your component diagrams. And here we don't have symmetry, so I have to draw out two separate diagrams. I'll do that and come back to you. Alright, so let me explain some things here, because you might want to have your algebra books handy or your trig books handy. There's a lot of heavy-duty trig, geometry, and algebra right here. So I have the two blue equations. Bottom line here, what I'm ending up with is 6 equations with 6 unknowns. So it's a system of equations that I got solved by algebra. And the general rule is this: if I have 6 unknowns, if I have 6 unique equations, I can probably solve that system, either using substitution or matrices or whatever. But I'm going to use substitution here in a second, but I'm getting ahead of myself. I've drawn the component diagrams for each of the two tensions. T sub 2 in black over here. And if you look at that and figure it out from geometry, I've labeled that one angle 15 degrees, which is the complement of 75 degrees based on the diagram that I was given. So I have expressions for T sub 2x and T sub 2y in terms of T sub 2, just using your sine and cosine functions and applying it to the component diagram. Once again, there's a lot of expressions here with actually no actual numbers quite yet. We'll get to that. This will be solvable. I did the same thing for the red T sub 1 vector, the components in terms of T sub 1, applying sines and cosines. Once again, really the physics is all done. The physics was done in the blue diagram. This is all now algebra, plugging in all these expressions. Basically what I'm going to do is plug these expressions from the black and the red into the blue equation. I might not do the whole thing, but for example, if I take, say, this relationship right here. Well, let's start with the other one. Let's start with this one right here. You can start anywhere you want, but I have T sub 1y equals T sub 2y plus 10. So I look over to the left-hand side over here. You got to be really careful here. Here's my T sub 1y and my T sub 2y. I'm going to take those expressions and plug them in. In other words, what I end up with, if I plug those in, I end up with T sub 1 sine of 60 equals T sub 2y, which is T sub 2 sine of 15, plus 10. So I have an equation there, a new equation, which is the combination of those, excuse me, 3 things I have circled. But that equation has 2 unknowns in it, T sub 1 and T sub 2. Now, additionally, what I'm going to take is this equation right here. All right, I'm going to come down and substitute in. I'm looking for T sub 2x and T sub 1x. Let me switch to a different color here. Well, T sub 2x is right here, and T sub 1x is right here. So I'm going to set those equal to each other using substitution. In other words, what I have is, excuse me, I'm going to have T sub 2 cosine of 15 equals T sub 1 cosine of 60. Alright, so what I have there on the far right here now are 2 equations with 2 unknowns. I have a system of two equations with two unknowns. I can solve this. The best way to usually to do this in this situation is by substitution. In other words, take that blue equation I just wrote down there, and if I get that, if I solve for either t sub 1 or t sub 2, since t sub 2 is on the left here, I'll do it that way. T sub 2 equals t sub 1 cosine of 60 over cosine of 15. All right, so I've solved that for t sub 2. What I'm going to do is now take that red equation, sorry about all the arrows, I'm going to take this equation right here and get rid of the t sub 2. In other words, I just rewrite the equation. I'm going to have t sub 1 sine of 60 equals this big thing right here, I'll put this in parentheses, in place of t sub 2. In other words, I'm going to have t sub 1 cosine of 60 over cosine of 15. That's what I'm substituting in for t sub 2, times the sine of 15, plus the 10. Sorry, I'm getting off the screen there. So that says t sub 1 cosine 60 over cosine of 15. That's what I substituted in, times the sine of 15 plus 10. So now I have an equation there with only one unknown. I'm going to let you finish this problem off. Basically, you take that equation that I have right there, and you evaluate. Sine of 60 is some decimal number, cosine of 15 is some decimal number, so you get a bunch of decimals there, and you use the rules of algebra to solve for t sub 1. Once you have solved for t sub 1, you're basically almost home free there. Then you go to any equation. I would probably take, and I'll circle it in black, this equation. Once I have t sub 1, all right, I would take that equation right there, or let's just, I would plug in that t sub 1 right there and solve for t sub 2, and then you have the problem finished off. But all the hard work has been done. There's just a lot of number crunching in algebra at this point to finish it off, and I'll give you some help with that if you're a little unclear about what steps to take to solve that using the algebra.